Good morning. Good morning. Hope all is well. Still see about 4 or 5 people still trying to connect, so I'll let them give them a chance to do so. Mhm. All right. So still some people still trying to connect, but let me go ahead and get into our notes. All right. So we have well, let me do this. Where's my page? Hold on, guys. All right, so we are right here, 17.7 today. And then from there, we have 3 more sections. Also, what I did, came with the idea of talking to one of your classmates. For each test, I posted a test review. You don't have to do them, not mandatory, but they'll give you a little practice going into your test. If you want it, like I said, they're not mandatory. You don't have to do them. Don't even have to open them up, but each test now should have a test review sitting in front of it that if you want to get some practice on problems that would be similar to what would be on the test, hopefully that'll help you guys out. But each one before the test, there's a test review set up like a homework. All right. Any questions on that? Everybody good? So. All right, so let's look at 17.7, last section in chapter 17, complex numbers. So complex numbers are created whenever you have a negative under the square root. So the square root of -1 will always produce I. That's how we will represent the square root of a negative value. So on this side, looking at our positive square roots, if I took the square root of +9, it's just 3, because 3 times 3 is 9. Square root of 121 is 11. Square root of 64 is 8. But if it was a square root of negative 9, it would be 3i. Square root of negative 121 is 11i. Square root of negative 64 is 8i. So whenever you have a negative under the radical, there has to be an I that represents that. Can't quite get rid of the negative representation. The way we would represent that is by I. All right. Even if you couldn't simplify it any further, simplify the number any further, let's say we had a square root of 17. Well, 17 is a prime number. So I cannot take the square root of 17 evenly. But because it's a square root of -17, what I can do is bring the I out. And so that would be I square root of 17 or square root of 17I. I just got to make sure that this, that square root don't extend over the I when you do your notation. So either one of those are fine. All right, questions, any questions before we go any further? Make sure we're okay. Here I have the square root of -18. So we talked about breaking up these numbers before. If you have a number that you can't take the square root of at least part of it, one of its factors, then you are expected to do so. So if you have the square root of 18, you can break that up into 9 times 2. But we have the square root of negative 18, so we can break it up into negative 9 times 2. Square root of negative 9 is going to be 3i. So these are the two ways you can represent that, leaving the 2 under the radical. 3i square root of 2 or 3 square root of 2i, as long as, once again, you don't extend your radical over that I, you're fine. Okay, here, just making sure we're emphasizing the placement of your negative and when to do I, when not to do I, when the negatives should still be a part of your problem, when not. So here, notice the negatives on the outside of your radical. So it's not affected by the radical. So that's negative square root of 49. Take the square root of 49, so that's negative 7. So the 7, excuse me, the negative is never affected by the square root. Now, if the square root or the negative is under the square root, then that's when the negative is affected. So here, this last one, negative square root of negative 49 will be negative 7i, because that negative is under the radical. All right, any problems, any problems? All right, next one we have 7 times the square root of negative 12. Once again, you break up that negative 12. It's negative 4 times 3. Square root of negative 4 is 2i. So 7 times 2i will be 14i, and then you leave your 3 under the radical. Any problems? All right, next one we have square root of negative 5 times square root of negative 15. So notice, have this statement right here, take the I out first. So what we did was, even though we couldn't take the square root of 5, couldn't take the square root of 15, I can take the square root of that negative. So I bring the I out. So that's I square root of 5, I square root of 15. Multiply what we have together now. I times I is I squared. And then 5 times 15 is 75. Then you see my next statement right here, never leave I squared as a part of your final answer. So whenever you have I squared can always be simplified further. So you see right here, I squared is going to be negative 1. And this is just a breakdown right here. You don't necessarily have to remember the breakdown, but if you remember that I squared is always going to simplify to negative 1, that's what you always need to remember. All right, so finishing off the problem, I squared is negative 1. And then we break up 75 into 25 times 3. Take the square root of 25 is 5. So that'll be negative 5 square root of 3. Any questions before we go to the next one? All right. All right. So here, square root of negative 39 over square root of 3. Once again, take out the negative first. So that's why we have I. Cannot take the square root of negative 39 evenly. So but what we can do is simplify this square root of 39 over the square root of 3. 3 divides into 39 leaves you with 13. So that's I square root of 13. Yeah, any problems? Any problems? Hold up. All right, so that takes us into complex numbers, a plus bi, where you can have a real part and an imaginary part. Standard form, they will mention what we call standard form. And that just means you will write the real part first. So notice the real part and then imaginary part. Scrolling up. So when it comes to adding, subtracting complex numbers, basically all you're doing is combining your like terms. So here we have 7 plus 3i plus 2 minus 5i. So 7 and 2 is 9. 3i and negative 5i will be negative 2i. So you're just combining your like terms. Subtracting, if we have 11 minus 6i minus negative 8 plus 4i, notice the first thing we do is distribute that negative to each term that follows the minus sign. Notice that turns both of our signs to the opposite. So now we have 11 minus 6i plus 8 minus 4i. Combine your like terms now. We have 11 plus 8 would be 19. Negative 6i, negative 4i is negative 10i. Questions? Any questions?
Yes, sir.
All right, sounds good. Sounds good. Of course, if I scroll up too far, let me know. All right, next we want to multiply. We have 4i times 6 minus 9i. So 4i times 6 is 24i. 4i times negative 9i is negative 36i squared. Just like we mentioned before, I squared cannot be a part of your final answer because it simplifies to negative 1. So now we have 24i minus 36 times negative 1, which will give you positive 36. So we have 24i plus 36. But then to write it in standard form, you put your real part first. So that's 36 plus 24i. 36 plus 24i is final answer. All right. Any problems? Any problems? All right. Next one, 3 minus 9i squared. So we have to expand that out, doing 3 minus 9i times 3 minus 9i, and then distribute. So it'd be 3 times 3, which is 9. 3 times negative 9i, negative 27i. And negative 9i times 3 is negative 27i. Then negative 9i times negative 9i will be positive 81i squared. Now we can simplify, combine the like terms in the middle. Negative 21i, negative 21i is negative 54i. 81i squared. I squared, remember we said before, simplifies to negative 1. So what we have now is 9 minus 54i minus 81. And 9 and negative 81 will give you, that should be a negative 72. Left off that negative right there. Any questions? Next thing, complex conjugates. I believe we talked about conjugates before, just regular conjugates. That's just changing the sign of the middle. You know, signs change. So basically what we're saying is we're changing the sign of the imaginary part. We're talking about your complex conjugates. So if I have a plus bi, the conjugate of that would be a minus bi. Everybody still holding on to the last example? All right. So we have 4 plus 5i. Complex conjugate will be 4 minus 5i, and vice versa. That's why I have the arrow going back and forth. Negative 1 minus 2i, negative 1 plus 2i conjugates. And then 5i and negative 5i. Once again, we're changing the sign of the imaginary part. And here, notice my statement in green. When complex conjugates are multiplied, the imaginary part will cancel. And that's going to be something that helps us in the next thing that we do. All right, scrolling up. So when it comes to dividing with complex numbers, we're going to multiply the top and bottom, because remember, whatever you do to the bottom, you have to do to the top, vice versa. Multiply top and bottom by the conjugate of the bottom. So here we have 1 over 5 plus 2i. The conjugate of 5 plus 2i is 5 minus 2i. So we're going to multiply the top and bottom by 5 minus 2i. And right here is the result, but we have to get there, so I have to scroll down, just give you guys a chance to write. So, we wouldn't get to the result yet. Got to do the work down bottom. Give you guys a chance to write first, though. All right. So multiplying 5 minus 2i to the top and bottom. Notice I notated. Notice my numerator is my denominator work. So first in the numerator, 1 times 5 minus 2i. Of course, that's just going to be 5 minus 2i. In the denominator, we have 5 plus 2i. times 5 minus 2i. And that's what we have right here. So we distribute 5 times 5 is 25. 5 times negative 2i is negative 10i. 2i times 5 is positive 10i. And 2i times negative 2i is negative 4i squared. So I squared once again turns to negative 1. So it's negative 4 and negative 1, which is positive 4. 24 times 25 times, that's 25 times. 25 plus 4 is 29. So that's our new denominator. So that takes us right here to 5 minus 2i over 29. 5 minus 2i over 29. And then for complex numbers, you have to break it up and write it this way. So that 29 went to both terms in the numerator. So it's 5 over 29 minus 2i over 29. And that would be your complex number. All right, questions on that? Any problems before we go to the next thing? So last thing of this section is powers of I. So we already know I is just going to be I. I to the first power is just I. And we talked about I squared, which is negative 1. Now I cubed is going to be I squared times I. But we said I squared was negative 1. So I really could have went one more statement here and wrote negative 1 times I, which is negative I. All right. So I squared is negative 1. Negative 1 times I is negative I. And then this last one, I to the fourth, is I squared times I squared. 2 plus 2 is 4. And I squared and I squared, negative 1 times negative 1, which is positive 1. All right. So those are the 4 main versions of I, as far as the powers of I. Everything else is going to be repeating as multiples of 4. So notice when you look at I to the 5th power, going to get I to the 6th power, negative 1, I to the 7th power, negative I to the 8th is going to be positive 1. So every 4th power, you're repeating this same cycle. So I give you a chance to copy that. Then I'll go to the next statement. All right. So statements on how we can break this thing down. Make that better. So every multiple of 4 is equal to 1. Mentioned that. But to simplify any other power, you look for the highest multiple of 4 that's less than the power in question. So I'll show you that in a second. Just give you a chance to write. Right. So just look at some examples of doing this. So I to the 16th power is 1. You know, any multiple of 4 is going to give you 1. So that means I to the 100th power will also be 1, because, you know, 100 is divisible, easily divisible by 4, evenly divisible by 4. Now, let's say if I have I to the 37th power, that's not divisible by 4, but what I do is look for the largest number that's divisible by 4 under that power, or less that power. So less than that power. So 36 would be the highest number under 37 that's divisible by 4. So I break it up into 36 and 1. 36 plus 1 is still 37. But I to the 36, because it's a multiple of 4, is going to give me 1. And then I'm left with just I. So that result would be 1. I. So if I have I to the 26th power, the largest number under 26 is 24. Largest number divisible by 4 that's under 26 is 24. So you break it up into 24 plus 2, which is still 26. And then I to the 24th gives you 1. And we already know I squared gives you -1. So 1 times -1 is -1. And then last one like this, I to the 43rd power. Once again, the largest number that's divisible by 4, that's under 43. That's what you should be looking for. In this case, it's 40. So I to the 40th power still gives you 1. Then I to the 3rd power, we talked about, gives you -I. So your result will be -I. All right. Questions on what we did here? Make sure we're okay. Any problems? Any problems? All right. Anybody still copying before I go to the next thing? All right. So just reemphasizing what's going on, because I know a few people came in after I said this. So a few things. We just closed out chapter 17. So 17.7 was complex numbers. So we're done with that. So we have 18.1, 18.2, and 18.6 to cover as far as new material is concerned. After that, it's just really about, you know, reviewing. You come into class, answering your questions. We will have days where we can, allow tests to be taken as well. But that's, like I said, that's after we've covered, these 3 sections. And then we'll go from there. Also, what I added to your assignments that are not mandatory, but I would suggest that you take advantage of them, is that before every test is the test review, which gives you the opportunity to practice problems that are very similar to the problems that will be on your test. So and they're set up as a homework so that you can do it as many times as you like. So every test now has a test review sitting in front of it. All right, not the review quiz, but the actual, notice it says test review. Once again, they are not mandatory. If you never open them up, or if you do it, only do 20% of it, it will not, affect your grade at all. All right. Any questions, concerns, comments on anything? Everybody good? Everybody straight? All right. So next class, I'll open up the floor for questions. If you don't have any questions, then we'll just get into 18 and get ready to close it out as far as new material is concerned. And once we do that, then it's all about, prepping you for your tests to make sure everybody's successful in their test, getting a 75 or better. All right. So if you guys are good, I'm good. Have a great weekend. Be safe. If you want to come tomorrow to take a test, feel free. It's at 9 o'clock. And then go from there. Somebody just asked that. Yep. 9 o'clock. Yep. All right.
Thank you, sir.
So,
Not a problem. Have a good one. Take care.
so Mr. Tucker,
Yes, sir.
is there anything I need I need to do to take the chapter 10 post test?
You talking about if you want to do it tomorrow?
Yep.
No, I sent the link already for office hours. It's an office hour link on Friday at 9 a.m. It's that same link. You just come in, let me know which test you're trying to take. You told me 10, but just remind me that, when you come in, and then I'll give you the password and you can just take the test during that time.
Okay.
All right. Sounds good, sir.
Good.
All right. Anything else? Anybody else before we close out? Everybody good?
No, thanks.
All right. You guys have a good one. See you next class. Take care.
Have a great day.
You do the same.